Today we'll be running a transient nonlinear pull test on a coupon in solution 401. Then we'll release the enforced displacement constraint to see how much the part springs back. We'll begin by creating our simulation models and a new Nastran multi-step nonlinear solution 401 with large strains and material nonlinearity turned on. We'll create our first nonlinear static subcase with an end time of 1 second and 50 increments. Next we'll put a brick mesh on the part. Now because we want to plastically deform the part, we'll need to assign a material that has nonlinear properties. So here we'll select a material out of the library, steel rolled, that has a stress-strain curve. Next we'll make our subcase active because we want to create subcase constraints so that we can change them from one subcase to the next. So here I'll put a fixed constraint on the bottom of the part and we'll put an enforced displacement constraint on the top. And we want to pull it in the Z direction, DOF3, with a table-based field. And that field will be a function of time. And we'll specify at time 0 our enforced displacement will be 0, and at time 1 our enforced displacement will be 1/10 of an inch. Next we'll clone this solution to duplicate it. Then we'll edit the ending time to be 1.1 seconds with 1 increment. And in this subcase, we're going to remove the enforced displacement constraint. Now we're ready to run. Here I've paused the video, but you can see that it takes 14 seconds to run. And we can view our results. So here, let's take a look at that last time step in our last subcase, and here you can see that spring back. It was 1/10 of an inch enforced displacement that is sprung back to 93 thousandths. Here we can also plot that displacement as a function of time and probe the various locations. So that is how to run a transient nonlinear plastic analysis in solution 401 to see how much the part springs back after the enforced displacement is removed.